The National Electrical Code (NEC) requires all new lighting fixtures to be compatible with 90°C supply conductors, as stated in Article 410.110. Older homes often have 60°C supply conductors, which might not be directly compatible with the connectors found on newer fixtures. When addressing this incompatibility, several methods can be employed. Firstly, you could choose new fixtures that are specifically rated for compatibility with both 60°C and 90°C supply conductors. Secondly, installing a junction box in the ceiling is a viable option. This involves connecting the existing 60°C supply conductors to the junction box, then connecting the new fixture to the 90°C connectors within the junction box. Thirdly, reducing bushings can be used to adapt the 60°C supply conductors to the 90°C connectors on the fixture. When utilizing reducing bushings, it is imperative to ensure that they are appropriately rated for the temperature and current rating of the conductors involved. Older wiring types, such as knob and tube, K and T wiring, present their own considerations. K and T wiring typically has a maximum temperature rating of 140 degrees Fahrenheit. However, it is generally not recommended for use with modern fixtures that generate significant heat. Regarding cloth-style Romex, older Romex insulation may have a lower temperature rating compared to modern insulation. Therefore, it is crucial to check the manufacturer's specifications for the specific cable type in question. When it comes to acceptable practices, several approaches can be considered. Heat shrink tubing applied over old insulation is generally acceptable for providing additional protection against potential heat damage. Reducing bushings that are rated for the temperature and current rating of the conductors are an acceptable method for adapting 60°C supply conductors to 90°C connectors. In summary, what should you do? Firstly, consult the NEC to ensure full compliance with current regulations. Secondly, determine the compatibility of the new fixture with the existing supply conductors. Thirdly, choose an acceptable method for connecting the fixture, such as installing a junction box or utilizing reducing bushings. Fourthly, carefully consider the temperature rating of the old insulation and implement appropriate measures to protect against heat damage. It's essential to be aware that ignoring these compatibility requirements can lead to electrical hazards, including overheating, arcing, and potentially even fire. Always prioritize safety and adhere to recommended practices. Article 410.110 covers temperature limitations of the conductors and lighting fixtures and how they are rated. It specifies that the branch circuit wiring supplying a lighting fixture should have an insulation temperature rating sufficient for the temperature encountered in a fixture. This is to ensure that the heat generated by the fixture does not degrade the wire insulation, which could lead to short circuits or fire hazards. The article also requires that the fixture be marked with the required temperature rating of the supply conductors. This marking helps to ensure that the correct type of wire is used when installing the fixture. In general, modern fixtures are designed to be used with wires that have a 90°C insulation rating. This is because modern fixtures, especially those that use high-intensity lamps or LED arrays, can generate a significant amount of heat. However, older homes often have wiring with a 60°C insulation rating. This wiring is not suitable for use with modern fixtures, as the heat generated by the fixture can cause the insulation to break down. There are several ways to deal with the situation. One option is to replace the existing wiring with new wiring that has a 90°C insulation rating. This is the most reliable solution, but it can also be the most expensive and time-consuming. Another option is to install a junction box near the fixture and use short lengths of 90°C rated wire to connect the fixture to the existing wiring. This is a less expensive option than rewiring the entire circuit, but it is important to make sure that the junction box is properly installed and that all connections are tight and secure. A third option is to use a special type of wire connector that is designed to be used with both 60°C and 90°C rated wire. These connectors are typically more expensive than standard wire connectors, but they can save time and money in the long run. Finally, it is important to note that some older fixtures are designed to be used with 60°C rated wire. If you are installing an older fixture, make sure to check the manufacturer's specifications to determine the correct type of wire to use. In addition to the temperature rating of the wire, it is also important to consider the ampacity of the wire. Ampacity is the measure of how much current a wire can safely carry. The NEC provides tables that list the ampacity of different types of wire based on their size and insulation type. When selecting wire for a lighting fixture, it is important to choose a wire that has an ampacity that is sufficient for the load. This will help to prevent the wire from overheating and causing a fire. Knob and tube wiring is an early type of electrical wiring that was commonly used in homes built before the 1940s. It consists of single insulated wires that are supported by porcelain knobs and run through porcelain tubes where they pass through framing members. Knob and tube wiring has several disadvantages compared to modern wiring. Firstly, it is not grounded. This means that there is no path for electricity to flow back to the source in the event of a short circuit. As a result, knob and tube wiring is more likely to cause electrical shocks and fires. Secondly, knob and tube wiring is more susceptible to damage than modern wiring. The insulation on the wires can become brittle and cracked over time, which can lead to short circuits. Thirdly, knob and tube wiring is not rated for the same amount of current as modern wiring. This means that it cannot be used to power modern appliances and lighting fixtures. If you have knob and tube wiring in your home, it is important to have it inspected by a qualified electrician. The electrician can assess the condition of the wiring and recommend any necessary repairs or upgrades. In some cases, it may be necessary to replace the knob and tube wiring with modern wiring. Cloth-covered Romex is another type of older wiring that is commonly found in homes built before the 1960s. It consists of insulated wires that are wrapped in a cloth covering. Cloth-covered Romex has several disadvantages compared to modern wiring. Firstly, the cloth covering can become brittle and frayed over time. This can expose the wires and create a fire hazard. Secondly, cloth-covered Romex is not rated for the same amount of current as modern wiring. This means that it cannot be used to power modern appliances and lighting fixtures. If you have cloth-covered Romex in your home, it is important to have it inspected by a qualified electrician. The electrician can assess the condition of the wiring and recommend any necessary repairs or upgrades. In some cases, it may be necessary to replace the cloth-covered Romex with modern wiring. When working with electrical wiring, it is always important to take safety precautions. Firstly, always turn off the power to the circuit before working on any wiring. Secondly, use insulated tools. Thirdly, wear rubber gloves and eye protection. Fourthly, never work on electrical wiring in wet conditions. Fifthly, if you are not comfortable working on electrical wiring, hire a qualified electrician. The NEC is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and safety practices. The NEC is used by electricians, inspectors, and other professionals to ensure that electrical installations are safe and code compliant. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It also includes requirements for specific types of equipment, such as lighting fixtures, appliances, and motors. The NEC is a complex document, but it is essential for anyone who works with electrical wiring and equipment. It is important to stay up to date on the latest changes to the NEC in order to ensure that your work is safe and code compliant. When installing a new light fixture, it is important to follow the manufacturer's instructions carefully. The instructions will provide information on the correct wiring methods, overcurrent protection, and grounding requirements. It is also important to make sure that the fixture is properly supported and that it is not installed in a location where it could be damaged. If you are not comfortable installing a new light fixture yourself, hire a qualified electrician. A qualified electrician will have the knowledge and experience to install the fixture safely and correctly. Over time, wire insulation can degrade due to heat, age, and environmental factors. Damaged insulation can create a significant safety hazard. increasing the risk of electrical shock and fire. Regular inspection of wiring is essential, especially in older homes, to identify any signs of degradation. If damaged insulation is found, it should be repaired or replaced by a qualified electrician. While heat shrink tubing can provide some additional protection for old insulation, it is not a substitute for proper wiring practices and may not be suitable in all situations. Always consult with a qualified electrician to determine the best course of action. A junction box provides a safe and convenient location to make electrical connections. It is a metal or plastic enclosure that protects the connections from damage and prevents accidental contact. When extending or modifying existing wiring, it is often necessary to install a junction box to house the new connections. Junction boxes should be properly sized to accommodate the number and size of conductors being connected. They should also be securely mounted and accessible for future maintenance. Reducing bushings are used to adapt different sizes of conduit or fittings. They are typically made of metal or plastic and have a tapered shape that allows them to be inserted into a larger opening and then tightened down to secure a smaller conduit or fitting. Reducing bushings are commonly used in electrical installations to connect different sizes of conduit or to adapt conduit to a smaller fitting. When using reducing bushings, it is important to ensure that they are properly sized and installed to provide a secure and watertight connection. The temperature rating of a conductor refers to the maximum temperature that the conductor can withstand without degrading its insulation. Conductors are typically rated for 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. It is important to select conductors with a temperature rating that is appropriate for the application. For example, conductors used in high-temperature environments such as near lighting fixtures or heating equipment should have a high temperature rating than conductors used in cooler environments. The ampacity of a conductor refers to the maximum amount of current that the conductor can safely carry without overheating. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature. It is important to select conductors with an ampacity that is sufficient for the load being served. Overloading a conductor can cause it to overheat and potentially start a fire. Electrical safety is paramount. Always prioritize safety when working with electrical wiring and equipment. If you are not comfortable working with electricity, hire a qualified electrician. Ignoring electrical safety precautions can have serious consequences, including electrical shock, fire, and even death. Always follow the NEC and other applicable codes and standards to ensure that your electrical installations are safe and code compliant. When dealing with older wiring, it is important to be aware of the potential hazards and to take appropriate precautions. Older wiring may be damaged, deteriorated, or not up to current standards. It is important to have older wiring inspected by a qualified electrician to determine its condition and to identify any necessary repairs or upgrades.